Well, welcome everybody to this GigaOm webinar, Relational Databases in the Cloud, Masters of Federation. My name's Andrew Brust. I lead the data and analytics category of stuff at GigaOm, and our sponsor today is Cockroach Labs. And we're very happy to have them because their domain expertise in this field is especially good. I wear many hats. I cover data and analytics as both an analyst and a journalist. So you may see articles by me in this space, both on VentureBeat and also the new Stack. Again, within GigaOm, I'm leading that category. And I've been working with databases since the 80s and business intelligence and analytics since the 90s. I'll leave that as the abridged version. I'll let you know that Jim Walker is our guest. He's Principal Product Evangelist at Cockroach Labs. And Jim, first of all, welcome. But second of all, beyond name and title and serial number and so forth, tell us a little bit about your history in this industry, because I happen to know it is pretty substantial.
Well, yeah, and Andrew, I think I first met you somewhere around the 2011, 2012 timeframe.
That's right.
And, I've enjoyed our relationship that whole time. I mean, I've learned a lot from you in terms of your deep experience in data as well. I'm lucky. I get to talk to a lot of analysts and smart people about data all the time, and I thoroughly enjoy this. So I've really been looking forward to this conversation, Andrew. So I'm really happy to be here. My background, y'all, I was a developer way back in the day, not as far back in the day as Andrew, but almost as far back. I coded, coded in a bunch of different languages, but I was always the person like they put in front of people to explain what was going on. So I naturally gravitated to, really the role of product marketing, which I think is the role of like the translator between deep technical stuff to like, making it kind of consumable for a lot of people. I'm a startup junkie, I guess you would call that. This is my 10th startup in a row. All of them have been pretty interesting. Just dabbled around in data for about 20 years, 25 years or so. I was in master data management. I worked at a company called Talent. I owned, like some strategy and some direction there. I was very early days in the Hadoop game, and that's where I met you, Andrew. I was at Hortonworks, really helping the world kind of understand what that was going to be. And that was a fun run. And then after that, I really dove a little bit deeper in the infrastructure. And I really got interested in distributed systems. I joined a company called CoreOS, which was really helping kind of drive the whole Kubernetes thing early days. Helped, with the organizers of KubeCon and all these things. And I was in distributed systems, and I was, back in the early days of Kubernetes, it was like, oh, this is for stateless applications. And I don't know, maybe I'm just an old developer, but there's always a database. Like, in fact, I think an application is nothing but an interface between a user and a database. Like, that's the way I think about these things. And so how can it not be distributed? And so when I saw Cockroach Database, and I joined here about 3.5 years ago, so I was first introduced to Spencer and the CEO about 6 years ago. I just couldn't unsee it. I kind of knew I was going to work here because I think underneath the covers, what's going on here is kind of truly something special. And fast forward to today, where is cloud adoption a question? No, like, this is kind of the modern world we live in. This shift to distributed systems and a kind of a different paradigm. I think these old databases and the way they were is going to actually transform. I think that's what we're going to talk about here today.
We're going to talk about what's old is new again, but also important differences, right? How a trusty old architecture has adapted to a very new world, and
that's right.
Some things
so Andrew, my job now, I was product marketing here at Cockroach Labs for like 3.5 years. I've now moved on. Now I'm just an evangelist. I go out and talk to cool people like you. So I enjoy it. It's a lot. I feel like it's kind of like an analyst job. I just go out and talk and stuff. Do you get? I guess y'all do research too. I know. So
some a little bit.
You have to.
Yeah, indeed. And you mentioned Hortonworks, and it was in the Hadoop world. Hortonworks was a spinoff of the Hadoop team from Yahoo. So the seminal internet company, really. All right. Well, let's kind of advance into what we're going to talk about. The relational database is a really interesting thing because it's more relevant than ever, but it also dates back to the 1970s. So how can this thing that's decades old be so germane right now? We want to talk about kind of both ends of that timeline. Um, Obviously, the cloud figures in here quite a bit, and what that means is, especially if something that's been around for decades is still relevant, well, that probably means we're going to want to migrate some of those things to the cloud, and we're going to need to talk about a few different ways to do that, kind of good, better, and best, maybe. Um, and then what has really changed with databases all up, and certainly with relational databases, is the ability to distribute them. But distributed database means lots of different things. And I'm not going to step on the punchline any more than that, but we're going to talk about the various ways something can be distributed and then bring it home with this idea of the database as a control network. So some of that may be a little cryptic, but that's okay because we're going to go into each thing and we're going to start off with the database historically. Again, this goes back several decades, even before I was coding. Hard to believe, but true. Uh, and these things just seemed so modern at the time. The notion of tables and rows and columns was actually a big change from the file-based systems that existed both on the mainframes and on the PCs. Can you talk a little bit about this construct and why, I don't know, why it seems so classic, why it continues to work?
Yeah, Andrew, I mean, if you, I'm also, I'm a little bit, I'm a child of history as well, a bit, right? And I kind of look to the past to kind of see what's going to happen. And, I think there's this interesting moment in time in the mid 80s where, the relational database really became kind of the default system of record for everything we were doing. I remember when I first started coding, I was on, I coded on top of something called Fox Pro. So anybody's kind of old enough, and then it was Access, and then, it turned into a bunch of other things. But I remember like I grew up thinking about tables and rows and columns, but if you take a step back and really think through, like, where did this come from? It's calculus. It's actually, there's math behind this whole constructs. And that was really developed in the early 80s, the late 70s. And kudos to Oracle and what happened in the mid 80s. Oracle basically said, look, this is the future of what, I think a lot of business is going to be. I think that was their vision way back then. And, they really kind of promoted and drove the whole SQL movement, which, when you talk about table, rows, and columns, we're talking about the relational model, right?
Right.
And then in the mid 80s, there was debate. Is it going to be the SQL thing, or is it going to be this thing called BASE, which was y'all could look it up, BASE. It was like kind of a different approach, and the SQL thing won. I think ultimately we ended up with like base based databases, like in the NoSQL world, but there was a lot of debate, and there was another language called Quell at the time. There's a guy by the name of Michael Stonebreaker. If you don't know who he is, actually pretty important in databases. Stonebreaker was like, yep, SQL's it. He started Ingress. He actually started the Postgres project at that point. So we've had these databases that have been around, and I think it's kind of like the way we think about data is correct. Normalization is a big thing. It still is a big thing. And these kind of, these traditional concepts in the relational database. And I think these databases are rock solid today. We're talking about mid 80s to now. I don't know, I can't even do that math. It's like 35 years of working on these things. And I think, today more than ever, understanding data and understanding this system of record for the kind of the operational data that drives organizations, it's critical. I'm sure we'll hit on, like, a little bit on the differences in NoSQL and SQL and kind of why that's important. But the SQL stuff is just super important. And it's the stuff that you're talking about here, Andrew.
I think, one thing I like to point out is that even though spreadsheets ought not be used as databases, the geometry is the same, right?
That's
I
right.
mean, you have rows, you have columns, and ever since, 20 years ago, you have multiple tabs inside of a single spreadsheet file. Those tabs are tables. It's almost the same word. And the rows and columns are there. I have a feeling it's, I don't know if anyone studied this cognitively, but I think it's just a basic construct that the human mind works with well.
I
Uh,
think so. When I got introduced to like the document model, I let go of the document model somewhere around XML, Andrew. I just, it didn't make sense to me. You know what I mean? I didn't understand this huge, like to me, the structure and the data integrity that tables and columns and referential integrity and indexes provide, to me, that's a mathematical approach to what we want to do. Whereas like document model is more like free range, like, it's kind of like left brain, right brain a little bit, right? I think that's the way I think about these things.
Yeah, I think so too. And just one more point at the bottom of the slide is that the relational database proved so just so agile and flexible that it turned out that even though it was really designed for operational use and mostly for writing data or updating data or retrieving small batches of data, it also then served as the basis for the data warehouse. And so in fact, you see relational databases used for both operational um, and analytical workloads. And that's really, I don't know, that's really kind of impressive. We take it
Hmm.
for granted now, but the fact that it works that way is super important.
Yeah.
So that's where things were. And then yes, you mentioned NoSQL databases. Along they came, along and with an attitude of sort of like, I don't know, SQL and relational somehow was outmoded and was going away. And of course that just didn't happen. No matter how much, the industry or a part of the industry may have wished that on itself, that was a kind of magical thinking that didn't work out. The SQL skill set is ubiquitous, and again, this notion of thinking in tables, columns, and tables, rows, and columns is just such an ingrained way of thinking that to imagine it would go away was a bit, probably a bit naive. So now relational databases, well, first of all, they're doing everything that they did over the decades, right? That doesn't go away. It's cumulative. It's a superset. But now, especially with the cloud, we've got lots of other things
That's right.
going on. Tell us a little bit, if you don't mind, about the different kind of, I don't know, the taxonomy of cloud relational databases. Some are kind of, I don't know, an adaptation. Some are more of a reimagining.
Yeah.
And we hint at that here. Can
Yeah.
you expand on that?
Yeah, and I think this story, and honestly, I could tie both things like this NoSQL came about, like this thing. I think we can tie this all together by looking historically about 20 years ago into what happened. And if I look to see what's going to happen over the next 5 to 10 years, I kind of look at see what happened at Google over the last 10 years. And Google is a pretty amazing company. I mean, you look at it, like search back in the late 90s, man, it was like Alta Vista and Lycos and Yahoo. And like, are you kidding me? You're going to create a search engine that's better? Well, it was simple. It was easy. Was it better? Probably. But did anybody really care? Not really. What Google did is they basically said, look at scale is a problem. And if we're going to actually meet the users of truly what the internet was, cloud, you had to rethink these things. And the NoSQL movement came out of Google. It's Bigtable. That's where it came from. Unfortunately, the industry took it and didn't really understand what they were really trying to solve. They had relational databases. They need data everywhere, quickly and available. So they took the rails off of SQL and said, okay, it's NoSQL. That's really kind of where that came from. There was a disconnect when it made it to the general public. Google
Yeah.
themselves said, look at this NoSQL thing is amazing, but you know what? We still need transactions and we need tables and rows and columns because you know what? Our lives run on these things.
Right.
And they created something called Spanner, which is like, it's phenomenal. And that, to me, that's like the beginning of this kind of distributed database movement, Andrew. And I think that's, if I look at kind of the challenges and really what this distributed systems thing is I'd like to really simplify things down into like the simplest words I possibly can. And I think in the old world, we think about like the model of the data, right? Like tables and rows or like the way it's going to look, the logical model. I think when you get to the distributed world, you have to overlay the physical model of the data because the physical model of the data is where it lives and why does it live where it lives? And we do that because we want to be able to survive failures in this distributed system, because all things fail. And like, especially as you have more components, like a node or a rack or a server or a region, a cloud provider, like these things fail. So where does your data live, and how do you survive that failure, right? How do I place it in the right places? Like, and then secondly, well, the speed of light's no joke, right? If data lives in Sydney and I'm trying to access it, it's going to take a long time for it to get here in Denver. And especially I'm doing like back and forth. And so I think, like my shortcut to understanding what's changed is you have to start thinking about the physical aspect of these things, like the where, like literally where those bits are changing in some server somewhere. I think that's really kind of the shift in terms of when we start thinking about distributed systems in generally in compute and coding, like literally. But I think in databases, it has some pretty interesting requirements are placed on the database today. And I think that's where things get really interesting.
I remember the first time I started working with a client server relational database platform, the dimension of showing off was how beefy your one server was.
That's right.
How many processors it had, how much disk it had, how much RAM it had. And then the notion came that you could actually sort of create a cluster with multiple servers. But everybody kind of quaked in their boots when it came to that, because managing that was, let's just say, a burden. And the people who did that were often short on sleep. They went to bed with their beepers on. and
That's right.
And it was, it took a certain personality type. Then along came the NoSQL databases, and they're like, you want more nodes?
That's
Just
right.
add the IP address
That's
of the
right.
server to the list, and we'll take it on. So it looked like we had this very stark choice of scale it out really easily, but lose kind of all the things you counted on in a database,
That's
or
right.
go to the traditional platforms where you have referential integrity and you have transactions and you have SQL, but you're going to have to deal with the fact that like scaling it out to multiple nodes, it's next to impossible. It takes a degree in witchcraft to do it. And I don't know, that seemed like the choice.
And Andrew, that's been the state of the art for these databases for the last 20 years. Basically, to scale a database, we used to do we used to joke about this. Like, okay, what we would have a budget for a project. It would be like, okay, great, go talk to the big red company and figure out how big your database is going to be. Figure out what that budget is, and then the rest of the budget you had left, you would go buy the biggest server you possibly had. Right, you go the biggest Sun Spark engine you could possibly get and run that thing on it. It was great. You know what I mean? That was the top of our scale. If you wanted to get better, bigger machine. Okay, along came sharding. Okay, that's complex, but that's state of the art and it works. And it does. And we're getting horizontal scale. And then this kind of concept of like active passive systems and primaries and secondaries and failover and these sort of things, that has been state of the art in the relational database side for what, 20 years, 25 years, right?
But it
and
still scares me to talk about it.
But that's what we do. That's how we
Right.
get there. And so NoSQL presented a different way, but I lost a bunch of things.
Yeah.
Right. And what's happened is we as developers and the software engineering community, we learn every day and we push the bounds of what we know in software engineering. And where we're landed right now is we're just at the resultant outcome of years and years of development and research, honestly. And so
but now we kind of have the best of both, right? It turned out we didn't have to make these stark extreme choices.
That's right. And that's what's going on right now. It's like it's just, I'm just proud of to be a software engineer, like, because we have basically pushed the bounds, and it's going to continue to do this. I mean, one day we'll beat the speed of light. I don't think I'll be around, but that's a whole other world. But
right.
That's what's going on, I think.
All right. So if I don't have to choose anymore, if I can scale out and still have all the creature comforts of SQL and relational, and if that typically happens in the cloud, then I'm all in. I want to move to the cloud. So how do we do that? Is there just a migration technique, or do we have a few?
Yeah, I mean, I think that,
segue here.
Right, right. And you and I have talked about this at length a couple of times, Andrew. And I think this is just kind of the practical reality of what we're seeing out there. It's like people take a database, they run it on a VM, they throw it on, some cloud EC2 instance or GKE or Azure or whatever that is, and I'm in the cloud. Great. Like I have actually had huge benefits because the benefit of the cloud is how do I move from CapEx to OpEx from a cost center point of view? That's a big deal for people. Maybe I don't have to buy infrastructure more. I don't have like a room with servers. Like that was a big move for people, and I think that's kind of that first thing. But you aren't actually gaining the benefit of what really cloud infrastructure was built on. And cloud infrastructure really lends to and really kind of starts to push people towards the concept of, truly ubiquitous and global infrastructure that's distributed. And I think, what we've seen, some databases do is they like, oh, wait, we can do this. Let me just take what I had in the past and change it a little bit. Right. And that's kind of like this move and improve, whereas like re-architect and rebuild is what Google did. Basically, they said, look, let's just throw away everything except let's take the core requirements of I need data modeling. I need, these strict, consistency and referential integrity. Let's make it with that, but then let's apply that to this new infrastructure. How do we re-architect these systems so that they can actually do that? And I think this is kind of what's going on right now. We're landing in this world where people are starting to re-architect and rebuild. We're doing it for the database. Y'all are doing it for your applications today. Like this move from the monolith to the microservice. Like this is happening all over the place. Why? Because there's massive, huge efficiencies in doing so. And I think people are starting to realize what that is. And the underlying infrastructure tools, and by the way, I think of database as infrastructure, all of that is changing at the same time. So it's a very interesting time in kind of all things IT. I think it's a whole lot of fun because there's a lot of change going on.
Without going into controversial current events, what I will note about kind of where the world is today is that it's a bit of a paradox. It's extremely connected in terms of commerce and, to an extent, culture. So we can't just operate within the bounds of, a nation's borders, and we can't operate our database within our four walls. On the other hand, each territory is sovereign, and as far as data goes, that sovereignty has impact. So we can't just blend everything together, and yet we can't be isolated and segregated. So the geographic equation here for data is super complex.
It is.
So can you talk a little bit about data protection regulations and how that both stymies me, but how I can transcend that and then kind of work globally?
Yeah, I mean, honestly, Andrew, I'm gonna save any current events for you and I getting Chinese food in Queens one day, but that's a wholly separate story, right? Like, but if you think about like, it's not just the nature of like what we're doing in data. Like, look at this company that I work at now. When we started the pandemic 2 years ago, they were like, you need to be in the office. Like, who are we today as a society? Like, literally. Like at the same time that these things are becoming distributed and it's blown out across the whole planet, we're doing that in our organizations. Like the parallels are incredible in terms of like how people work and then how our systems work. And what is that regulatory? What's that kind of system, that standard that we're all going to like agree to in terms of how we work, how we manage our data? There's kind of these really interesting kind of parallels going on in our world. And I think it's fascinating to actually watch this all happen at the same time. When we start to talk about data and jurisdictions and these sort of things, well, look at privacy laws that are popping up around the planet. I mean, California is going to have their own privacy law, right? Like Germany is pretty strict in terms of, what you can do with users' data and that sort of thing. And this comes back to this, when we started this conversation, Andrew, in this modern world, the location of data becomes incredibly important. This geographic kind of like where it lives on the globe becomes really, really important because look, man, like there's different laws in different places. For instance, like in the UK, if I'm a financial services institution, their rules about it, and it's not just like privacy. Let's extend it to another level. Like the rules for a financial services institution in the UK states that if you're going to deploy in the cloud, you need to be able to survive the failure of an entire cloud provider. So like, let's say, unfortunately, one of the CSPs just completely went away. Like your customers need to, like, you need to protect against that. Man, that's a tough one to actually deal with. I got to build this in 3 different clouds or one, like, oh my God, it's hard enough to build in one, right? Those type of like regulations are really, really difficult to comply with. So how do we build infrastructure that allows you to do that more easily? And I think that's the challenge that we have. And then God forbid the jurisdictional thing, and let's get back to data. Like, yeah, I mean, I have data privacy laws. Data that belongs to citizens of my sovereign nation need to live on servers that are physically located in my sovereign nation. What are you gonna allow your developers to basically code that into each application? Is that the right place to do that, or should that actually go into the database? Should that go into the infrastructure?
Well, that's
and,
just
and
it.
we govern that in that way. And to me, it's much more efficient to do it at the layer at which it's actually being controlled and regulated. And I think that's the stuff gets really interesting really, really quickly.
To me, that's the paradox, is that the equation for how the data gets managed physically is much more complex. But my need for that all to be abstracted away so I can just focus on the code and my business problem is just as acute.
That's right.
So the only way to platforms are the things that abstract. If I'm stuck writing the
That's right.
plumbing code for that very sophisticated plumbing equation, I'm probably doing it wrong. That
That's right.
said, a lot of people have been required to do that, but a platform that can do it for me is kind of what I need today. And what's interesting is that there are relational databases that work the way I used to code, but they can also deal with all
That's right.
these
And,
new
and
world requirements, the new world of work, the new world of data, the new world of commerce, and being connected, but also kind of respecting boundaries. Ultimately, that comes down to federation, I guess.
yeah.
And that's a complicated thing to code on your own.
Well, right. And Andrew, like, this is exactly what Google realized. Like, let's let that layer deal with it. Like, for instance, like the NoSQL versus SQL thing. Like, okay, if I don't have referential integrity in the database, like, what about the C in ACID, the consistency? Like, the data is going to be right. I've got to rely on developers to deal with that. Like, oh my God, like, literally, let's get the tool to do those things. The relational model fixes that. But can the relational model actually use the context and the constructs of NoSQL about scale and availability? Can we actually work that into the relational model? So I get both the data integrity is going on correct, but also this control over where things are happening. It's a very interesting, and again, it's software engineering advances have allowed us to do this.
Right. I think that if every development team has to code that stuff on their own, then obviously that's duplication of effort. And I know this will sound dramatic, but that is a kind of calamity economically if everybody's duplicating that effort when it could be done once in the platform. That's the whole point of factoring, right? Both in code and in math, right? You take
That's
what's
right.
common, you factor it, you do it once, you do it well, and then you add value on top of that.
That's right.
If we're not doing that, I know this will sound just hyperbolic. We're destroying wealth if we're making every individual application team have to write that stuff. It's bananas.
And then it's
Um,
people. So remember, it's also error prone, right? So like, let's just, I mean, and inconsistent. And then the regulatory comes along and they look for inconsistencies. And like,
mhm.
it's just, it's problematic in many different ways. And that's exactly, I love that word, Andrew. We factor it into a function. And that's exactly right.
So, but let's think about this a little bit. So the whole relational paradigm has been with us for a long time, and so have a lot of the relational platforms out there, and they can move to the cloud, and that creates an image that says, well, that's all I got to do. But everything you and I just talked about, like a lot of the incumbent platforms don't handle it. They weren't designed for it. Um, so what's cool is, and I'm, setting the table for you here, no pun intended on table. Um, but there are platforms that are consistent with the old
Yeah.
paradigm, but are savvy to the new realities of what technology requirements are. And you guys are one such platform, and there aren't a lot of them.
That's right. And the way we used to distribute data, and we still do this today. And I talked about active passive systems and these sort of things. What if I have a business here in the United States and I actually want to open up in Europe? What do? You bring up the entire system and servers in Europe, and then you synchronize data back and forth. Like this concept of like sending like asynchronously or synchronously, however you're going to do that, real time or not, it's problematic. It's complex. There's redundant systems. I think the biggest kind of like advance as humans over the past 10 years, there's a guy by the name of Eric Brewer, again, back at Google. And if you think about distributed consensus is this kind of new way of thinking about things. You don't actually synchronize, you gain consensus. And that's a fundamentally different way of looking at something. There's two algorithms. One's called Raft and one is called Paxos. And if people are really interested in how these things work, go check them out. There's a description of Raft on a website called The Secret Lives of Data that I think it's just phenomenal explanation of how this works. But basically what it states is instead of synchronizing is that when you write to a system and stuff is in different nodes, whatever that is, you can't commit it until like an odd number of replicas commit that. So like if you have 3 replicas, 2 of 3 of the instances of that have to commit, or 5 of 7 or 7 of 9, that kind of thing. And so like this is what I mean by the software engineering and like really taking a step back and thinking about, okay, how do we remove synchronization and actually have replace it with something that's fundamentally better? That's consensus. And it's pardon the pun, but it's your rose here. You use a pun. I'm going to use a pun too. But it's your rose here. Like, and how do I place data in these different, like, these are failure domains, in my opinion. Andrew, you know what I mean? Like, what do I want to survive?
These being the things on the slide, right?
Yeah, the things on the slide. I mean, these can be failure domains. Like, what do I want to survive, right? And so, like, I think it's a fundamentally different approach to thinking about like our tech and data, really, ultimately.
So, I mean, let's talk through these real quickly. I tried to use cute little icons that would help explain it. But, if we go back to the olden days where an entire table was in a file, well, that didn't scale well. So we can now partition our databases across files, or then we can partition them across disks, and that starts getting interesting. And ultimately, what we can do is shard them, which can even involve taking a single database and finding a key and putting different ranges of values for that key and in different places, maybe even on different servers. Okay, that's one way. Another dimension is, well, we don't have to, that thing that I talked about before where you showed off about how beefy your server was. Well, probably better to have multiple servers.
Right.
And now we have easy ways of doing that. And those multiple nodes form a cluster. Well, why can't we have multiple clusters? That's happening a lot in the data warehousing world. That notion that maybe you have a different cluster for each workload, but since the cloud likes to separate compute and storage, they can all actually work on the same physical copy of the data in cloud storage. But then what happens in the cloud where maybe a whole region goes down? You mentioned, data centers have outages. So if you're going to be real careful, you're going to put different assets across different regions, maybe US West and US East, or maybe across national boundaries. What if one cloud provider has an outage?
That's right.
Universally, it's on you to kind of prepare for that, to design for failure. That's the new ethos. So now you need to be able to actually have assets on different clouds. Well, not a lot of databases allow that. in some simple way where your entire infrastructure can be seen as one infrastructure, but can span those different clouds. And then what if you just have different databases in different places? That's what that last bit talks about. We've got databases on different clouds and different regions and so forth. How do I organize all of this?
Yeah.
And what do I use to organize all of this? I don't know. I'm bringing you down, but I'll bring you up now. So
I'm not down. I'm just listening, and I love it.
So we have this notion of, if I have a lot of databases and they're in lots of places and I need to keep track of that, what's a good place to keep track of something like that?
Yeah, it's interesting. It's kind of like, I always think about this concept of what's the logical database and where does that live, right? And how do I have a single logical database that does span multiple shards? Well, I have a sharding thing in front of it. How do I have a single logical database that's spanning across multiple nodes? Well, remember in the Hadoop days, well, we had this kind of, HDFS, and then we had MapReduce on top of that to actually do the compute. That was nodes, right? Like still a single logical database. Well, how do you do that across clusters, across regions? Like really difficult to do. And when I think about this, it's like, okay, I want a single logical database that's going to span lots of different places. And that's the magic here. That's really what this is. Like, and I can ask any member of that, any endpoint for that database for data, and it's going to find it no matter where it lives, cross regions, cross clouds, like all these different things. And that's exactly what we've built here at Cockroach Labs. And it's like I said, it was one of these things. Once I saw that, I couldn't unsee it, Andrew, because this conversation I had about 5 years ago, and I was like, oh my God, that's got to happen. Like the future of what we need to do needs to do that. Now, moving data around is difficult because cloud providers don't like you to leave data out of their things. So how do you control egress cost? By the way, that's another reason why you want to control data location, just cost. But if you think about this, like I think the modern way in which we think about deploying systems is as a service. And what is each of those instances of as a service? I don't know. Like I have a birthday app I built, and I sell it to you, Andrew, and you have it in New York, and I sell it to my friend. It's in London, and I have this kind of like I have a lot of like instances of databases. How do you what's the transactional system that's controlling all of that? What's the operational system that's controlling all of that? Because you are going to have data live in different places. Think about it from an analytics point of view. We work with a company called Starburst. Starburst is amazing, by the way, and the Trinio project's really cool. They're thinking about this from the analytics point of view because in analytics, you actually don't want to. It's kind of difficult to span regions because this cost and the time it takes to run queries, right? Like in analytics, you want everything in one region because the speed at which you're doing the analytics typically. Well, what if my data does live all over the place and I can't, consolidate? How do I federate that? And this concept of federation is what it is. Can the database serve as that federation layer that's actually allowing you to control what's where and understanding the metadata and how people are using it and the access controls to those things? You still need kind of one kind of structure, like one thread that's basically that layer and that control of, you say control of databases, like one control plane or control system that applies to both databases. From they could be operational, they could be analytical, whatever that is, but it also applies to our apps and services that we're all deploying today because these things need to live all over the place. And so there's metadata that's coming off of stuff, or there's metadata that's being fed into these things, that single kind of control, that metadata layer, it's just as important as the financial ledger. Like literally it's the same sort of thing, right? Like it's like, what's my common inventory across all my stores across the entire United States and Canada? I don't know. It's in 4 different systems. How do I know it in a store and what's online? I don't know. Those are all different systems. How do we have one kind of consistent transactional layer, one operational layer that's actually, that's reliable, it's not going to go away, and is going to scale not just from the volume of data and transactions, but it's going to have this geographic scale as well. And that's when we start to think about that. Like we as humans have advanced, and Cockroach Database is doing exactly that right now. I mean, I don't want to be just a shill for what we're doing, but I think this is the future of. We're talking about the future, what databases need to be, and this is why kind of legacy databases are going to struggle in this world. Dude, there's man, I tell you what, the legacy databases are amazing. Like literally, like they're our lives live on them. Our bank accounts, our healthcare records, the nuclear codes. This stuff works, but in the modern world, we're gonna have to eventually kind of shift these things. And so, what's the risk versus reward? And I think that's the stuff that organizations are going to. They're just starting to realize like we do need this kind of consistent plane.
Yeah, Jim. So that's to me, that's the paradox is that in computing today, we're kind of breaking things down. I don't mean breaking them like they don't work, but dividing things into smaller and smaller units, getting less and less monolithic. But all of that stuff has to be federated and associated back together so that logically we can address it as one kind of corpus of infrastructure. And
Right.
so it's that, I mean, that's stressful when it seems like we have requirements that are going in, rather opposing directions. But it seems like there's something that can pull those things together. And it sounds like from what you're saying, that really comes back to the database.
It does. It's the foundational layer of every business is the data. But I'll abstract it to another layer, Andrew. I think we live in a modern world of microservices and the context of an API is everything. How do I
Hmm.
expect I mean, I think every relationship is just like a broken API, honestly, like or a very poorly documented API. Like, ask your kids to go to bed and they say no. Ask your kid to go to bed and say no. You were expecting yes, right? Like literally, like, and we're looking at systems to go ahead and actually do that. And I think that's where the challenge is. With data, the API and the way we expect data to live and breathe and work is the relational model. And that's what we've built our business on. And this is the reason why the relational database is so important and continues to be important because that is the established API of the way that we manage and we work and we drive our data. Ultimately, like the relational database, that relational model, our tables, rows, and columns, like you had a couple slides ago, that is the API. That is the language. I hate the word lingua franca, but it kind of is, man. And like that's what's expected. If I ask it for something, it's going to turn the right data. It's going to be consistent. That's what we expect. And I think
Absolutely.
in this modern world, as we break things down, that API, those expectations out of our communications, that's what's important, and that's why the relational database doesn't go away. It's right.
All right. Well, I think that's an excellent place to wrap. I think we've talked about kind of the old, the new, how they've at once gone in different directions, but how that there is a consistency and then there needs to be something that bonds them together. And it sounds
Yeah.
like the relational database shows up in each of those spheres. So, Jim, I want to say thank you once again for being our guest on a really interesting webinar and conversation. And for GigaOM, this is Andrew Brust saying thank you to Jim, thank you to the audience, and we look forward to seeing you again soon on another webinar. Thanks.